In the 1950s, scientists first started testing a new type of bomb, 1,000 times more powerful than the atomic fission bomb dropped on Hiroshima during the Second World War.
3, 2, 1.
It was called the hydrogen bomb, and it was the first time mankind had recreated the way the sun makes its energy. Now, as massive as this bomb was, the energy it released was only a tiny fraction of the massive amounts of energy released by the sun every second. This demonstration is to help us try and show you how energy is produced in a star like our sun. Now, obviously, we couldn't give you an exact reaction that happens on the sun, because that would produce so much energy, you'd probably blow up your school, if not half of this country. So what we're going to do is we're going to give you a representative demonstration right here. You lot ready for this?
Yeah.
All right, we're going to have to step a bit back because it'll get really hot, and we have to make sure we got our goggles ready just in case. Now, this looks a lot better in the dark, so let's give it 10 minutes. This reaction of iron oxide and aluminium powder will create loads of energy in the form of heat and light. We're getting there. It can help us imagine the way the sun gives off heat and light, but on a slightly different scale. Was that pretty cool?
Yeah.
Right, so what we just saw there was a chemical reaction. But when you look at a star, the reactions that go on inside isn't a chemical reaction. It's actually a reaction called nuclear fusion. Nuclear fusion involves light atomic nuclei fusing to form heavier ones. The two nuclei are both hydrogen, and they join to form one helium nucleus. In our demonstration, the heat produced by the flames started the reaction. In a star, the reaction is started by gravity. The force squeezes all the hydrogen at the center of a star so tight that it gets hot enough for their nuclei to collide together with enough energy and speed to start fusing into helium. In this process, more energy is released. So in this reaction, it actually soared up to temperatures in excess of... Actually, let me see what your kind of guesses are. Well, what type of temperatures do you think it was?
1,000.
1,000?
2,000.
2,000?
3,000.
3,000? Exactly. You lot are on ball, aren't you? 3,000 degrees Celsius. But in a nuclear reaction, inside a star, temperatures are actually in excess of 15 million degrees Celsius. So that's about 5,000 times hotter than this reaction that just went off. Impressed? Yeah. And it's so hot that it's actually enough to burn through the metal of this can. So what I'm gonna do is, I'm gonna pull it off now that it's cooled down a bit. We've had it here for a while. So that was the top of the can. And this is the bottom of the can. When scientists tested the hydrogen bomb, they weren't able to control the amount of heat and light released. This made it a massive uncontrolled explosion. If scientists were able to carry out nuclear fusion in a controlled way, it would solve all our energy needs in one go. The sun produces 400 trillion watts of power each second. That means in a single second, the sun produces enough energy to supply the whole Earth with power for 500,000 years. So stars are like massive nuclear reactors. They're fueled by nuclear fusion, which releases huge amounts of energy, keeping the reaction alive so the star shines brightly in our sky. So inside a star, it's like 1 billion hydrogen bombs going off every second. Man, that's immense.